You wake up, thirsty. You reach for a glass of water, but nothing comes out. You rush outside. The ocean, gone. Rivers, vanished. The sky, clear. No clouds, no rain, no hope. Every drop of water on Earth is now speeding toward the sun. And what happens next will shatter everything you thought you knew about the universe. Understanding Earth's water. Before we can comprehend what would happen if we poured Earth's water into the sun, we need to grasp just how much water our planet holds. Picture this. If Earth were shrunk down to the size of a basketball, all of our planet's water, every ocean, lake, glacier, and raindrop, would fit inside a ping-pong ball. That's right, a single ping-pong ball. Let's put some numbers to this cosmic water balloon. Our planet cradles approximately 1.386 billion cubic kilometers of water. To visualize this, imagine a cube of water that stretches from New York to Los Angeles. Now stack that cube 4 times higher than Mount Everest. That's roughly how much water we're talking about. But here's where it gets interesting. 97% of this vast amount is salt water in our oceans, appearing blue from space and defining our planet's character. The remaining 3% is fresh water, and most of that is locked away in ice caps and glaciers. In fact, if you took a drinking glass of water to represent all of Earth's water, only a single drop would be readily available fresh water. Think about that for a moment. Every rainstorm that has ever fallen, every river that has ever flowed, every glacier that has ever formed, all of it combined is just a cosmic drop compared to the sun's immensity. And yet, this relatively small amount of water has shaped every aspect of life as we know it. Now, imagine gathering all of this water, every molecule, and preparing it for its journey to the sun. What happens next will challenge your understanding of both water and our star. The journey to the sun. Imagine every ocean, lake, and river on Earth rising into the sky, an unstoppable planet-wide tide abandoning the surface. Cities once bustling with life now lie barren, their streets coated in salt and dust. The atmosphere grows eerily silent as the last drops of moisture vanish. But where is all this water going? Straight toward the sun. The journey is nothing short of brutal. Space is a vacuum, meaning there's no air, no resistance, just 93 million miles of silent, merciless emptiness. The moment Earth's water breaks free from the atmosphere, it undergoes a violent transformation. With no atmospheric pressure to hold it in liquid form, it instantly boils away, turning into an immense cosmic cloud of steam. But the sun's gravity doesn't just let things drift, it pulls. This newly formed vapor cloud accelerates at staggering speeds, racing toward its fiery fate. Imagine tossing a snowball into a blast furnace. Now, amplify that 1 billion times over. As the water nears the sun, the rising heat strips away its molecular bonds. Hydrogen and oxygen atoms split apart, their identities erased before they even touch the surface. And yet, this is nothing to the sun. This star is 333,000 times Earth's mass, a nuclear inferno where 1 million planet Earths could fit inside. So, will Earth's water even make a difference? Or is it nothing more than a ripple in an ocean of fire? That's where things get truly insane. The impact. The moment Earth's water reaches the sun, reality itself seems to shudder. The sheer scale is incomprehensible. 1.386 billion cubic kilometers of water, enough to drown Earth under a 2.7-kilometer deep ocean, now slamming into a nuclear inferno. But here's the twist. It never touches the surface. Because before it can even get close, the sun destroys it. At 10,000 degrees Fahrenheit, water doesn't boil. It ceases to exist. The sun's heat doesn't just vaporize it, it rips apart its very molecules. Hydrogen and oxygen, once bound together in a life-giving embrace, are now torn apart at the atomic level. But this is where things get interesting. See, hydrogen isn't just a gas, it's the sun's fuel. Every second, the sun fuses 620 million tons of hydrogen into helium, releasing an ungodly amount of energy. And now, thanks to Earth's lost oceans, it's being fed a fresh supply. Does this mean the sun flares up, raging hotter than ever? Or does it barely notice, like a bonfire swallowing a raindrop? The truth is more complex. The sudden flood of hydrogen could trigger localized solar explosions, temporary bursts of energy much like solar flares. Imagine throwing gasoline onto a fire, brief, intense, but ultimately insignificant to the inferno itself. Because no matter how much water the Earth had, to the Sun, it's nothing more than a whisper in a hurricane. But back on Earth, that whisper just signed our planet's death sentence. Consequences. Earth is dead. The oceans are gone. The rivers, the rain, the mist that once clung to the morning air, all stolen. Without water, the planet is unrecognizable. A barren wasteland where continents have cracked apart, their once lush landscapes reduced to brittle dust. But this isn't just a drought. This is something far worse. Without water, the atmosphere collapses. There's nothing left to regulate temperature, nothing to trap heat. The days become scorching infernos, the nights colder than Mars. The very air thins as moisture vanishes, turning every breath into a desperate struggle. And then, the winds stop. See, without oceans, there are no clouds, no storms, no jet streams. Earth's climate, once a complex living system, becomes eerily still, like a corpse that no longer breathes. Meanwhile, 93 million miles away, the sun barely flinches. Yes, the hydrogen from Earth's lost oceans may have fueled temporary solar flares, but compared to the sun's 333,000 Earth mass, our entire water supply was nothing more than a drop in an endless cosmic furnace. For the sun, nothing has changed. For Earth, everything has. Because there's no coming back from this. No rain to refill lakes, no ice to melt. This planet, once overflowing with life, is now nothing but a silent, airless tomb. What if this happened on other planets? Imagine for a moment that instead of hurling Earth's oceans into the inferno of the sun, we decided to drown another planet. Would it create a new ocean world? Or would the results be even more bizarre? Mars, a short-lived water wonderland. At first, Mars would seem like the perfect candidate. The moment Earth's water crashed onto its barren surface, it would carve out new rivers, lakes, and even shallow seas. The rusty plains would darken, and for the first time in billions of years, Mars would look blue. But here's the problem. Mars has almost no atmosphere to trap heat. The newly formed lakes would begin to evaporate instantly, their vapor escaping into space due to Mars's weak gravity. Some of the water might seep underground, freezing into vast ice sheets beneath the surface. But in just a few hundred years, most of it would be gone, just like before. Jupiter. The water wouldn't even land. Now, what if we poured all of Earth's water onto Jupiter? Here's the terrifying truth. It would never reach the surface, because Jupiter doesn't have one. As trillions of gallons of water fell from the sky, they'd be ripped apart by Jupiter's monstrous winds, which rage at speeds of over 400 miles per hour. The water would be pulled deep into Jupiter's atmosphere, crushed under unimaginable pressure, and eventually split into hydrogen and oxygen, completely lost within the gas giant's chaos. A black hole, the strangest fate of all now. Let's push reality to its absolute limits. What if we dumped Earth's water into a black hole? The moment the first drop crossed the event horizon, time itself would warp beyond recognition. The water wouldn't just fall in, it would stretch infinitely, torn apart molecule by molecule in an effect called spaghettification. From the outside, it would look as if the water froze in time, never actually falling in, but from the water's own perspective, it would be swallowed whole in an instant, disappearing into the unknown. Would the black hole grow? Would it eject bursts of radiation? Would anything at all, ever escape? No one knows. And maybe, we never will. Conclusion. While we can't actually pour Earth's water into the sun, this thought experiment helps us appreciate both the immense scale of our star and the precious nature of Earth's water resources. It demonstrates why water is often called the molecule of life, and why finding it elsewhere in the universe generates such excitement in the scientific community. That's all for today. If you have enjoyed this video, don't forget to show some love by hitting that like and subscribe button.